here. Welcome to my video. In this video, I will be working on a linked list class and going through how it works in detail. The purpose of the lesson is to help you understand the basic data structure of a linked list in Java. Today, we will cover the following topics. What is a linked list class? You will explain the fundamental characteristic of a linked list and how it works. And second one, basic method of the list class, a list class. We will go through methods like add, remove, and then replace, contains, get length, and the last one is display. Third one, testing the linked list. We will test the linked list implementation using the a list test class here to see how it behaves in practice. Last one, time complexity. We will analyze the time complexity of each method for the best, worst, and average cases. Now let's dive into the code and then let's starting with private method. And then here is reference to the first node in the list, and then here is number of entries the list. Here we defined the list class, a list class. This class represents the linked list and is written as a generic class, which means it can be used with different data types. The node type first node holds the reference to the first element of the list. The number of entries keeps track of how many elements are in the list. And then here initially the list is empty here, and then here is list has no elements at the start, and then the constructor is called when an object of the class is created. It initializes first node to null, indicating the list is empty, and set the number of entries to 0. And then let's continue with add method, public void add, and here is create a new node with the given entry, and here is null. And then if the list is empty, the new node becomes the first node. And then here is traverse to the last node, and then here is set the last nodes to the new node, and then here is increment the number of entries. And then this method and the add method adds a new element to the list. If the list is empty, the new node becomes the first node. Otherwise, the traverses to the last node and appends the new node to it. Finally, the number of entries is incremented. And then let's continue with fourth one and add method with position. And then here is returning if position is invalid, print an error message and exit. And then here is create a new node with the given entry. And then here is if position is 0, set the new nodes next to the first node. And then here is the new node becomes the first node. And then current equals to current point. Next here is traverse to the node just before the target position. And then here is set the new nodes next to the node at the target position. And then here is set the current nodes next to the new node. And then here is increment the number of entries. And this add method allows you to insert an element at a specific position in the list. It checks if the position is invalid and then insert the new node at that position. And then let's continue with remove method. And then here is returning if position is invalid, print an error message and exit. Here is if removed the first node, point the next node. And here is traverse to the node just before the target position. And then here is skip the node to be removed by link to the next one. And then here is decrement the number of entries. The remove method removes to a node from a specific position in the list. It updates the references to bypass the node to be removed. And then let's continue with replace method. And then here is returning if position is invalid, print an error message and exit. And then here is traverse to the target position. And here is replace the data at the target position with the new entry. And the replace method replaces the element at a specific position with a new entry. And then let's continue with contain methods. And then here is again return true if the element is found. And here is move to the next node. And then here is return false if the element is not found. And the contain method checks if a specific element is present in the list. And let's continue with getLength method. And getLength method returns the number of elements in the list. And then let's continue with last method, display method. And the display method prints the elements of the list, showing how the nodes are connected. And here is print the data of each node, and here is move to the next node, and then here is end of the list. And okay, here is private static class node T, and T is data, and node T next, and here is this point data equals to data, and this point next equals to null is empty. And then let's running. Here is a list test Java class, and then here is writing, adding 10 and adding 20 and adding 30, and add position is 1 and new entry 15, and remove position 2 and replace position 1 and new entry 25. And here is print list contains 25, and here is printing this size and get length. And then the last one is printing display, and here is writing testing a list without tail reference, and list contains 25 is true, and list size is 3, and then 10 going to 25 and going to 13, and going to the last one is null and is empty. And alright, we have now covered the linked list class in detail. Let's summarize what we have learned. We understood the core concept of the a list, how linked lists work, how to add, remove, replace, search for elements, and get the length of the list. Second one, we examined the basic method. We went through method like add, remove, and replace, contains, get length, and discuss their time, the complexity. And the third one, we tested the linked list, and we used a list test class to perform various operation and checked that the linked list behaves as expected. And the last one is we analyzed time complexity. We rate how each method performs in best, worst, and average cases. And then by the end of this lesson, we have learned how linked lists work and how to implement them in Java. And then it can be okay. And thanks for listening. Have a good day. Bye bye.